So far, we've talked about the anatomy of the internet and how we figure out the address for the server that we want to talk to on the internet. But the part that we haven't talked about yet is how do we actually get on the internet? Or how does my local Wi-Fi access point or cellular connection get me onto that global internet? So if I have a mobile device that connects to the network, once I figure out what type of wireless technology I want to use, whether it's Wi-Fi or cellular, my next step is to figure out, number one, who I am, number two, who are the people in my neighborhood, and number three, how do I get onto the internet? So remember, we know that we need an IP address for people to be able to find us. The question then is how we figure out just what that IP address is. At this point, we'll assume that we figured out at least how to talk wirelessly. We'll come back in a later module to look at how that part works. For now, let's just think of our mobile device as having a valid wireless link. To get all of the relevant information that we need, our mobile device will invoke something called DHCP, or what's known as the Dynamic Host Configuration Protocol. Well, this is a bit of a mouthful. DHCP provides the answer to each of the three questions that we just noted. Who am I? Who can be found nearby? And where should I go to find those far away, aka who's on the internet? The first step of DHCP then on my mobile device is to broadcast or shout to find out anybody that will tell me or talk DHCP to give me an IP address. Ideally, this is a nearby router that will hear you and be configured to allow you to join to the network. If the router deems you okay to join and receive an IP address, the router then provides you a series of information to our mobile node. First off, it gives you the address. What is the address? My IP address on the global internet. Second, it gives you something called this net mask or subnet, which is who can be found locally without going on to the internet. Third, it gives you the gateway. How do I actually get onto the internet, or what's the next hop? And then finally, it gives you the address of the DNS server, which allows me then to translate those names into actual IP addresses. So once we get our DHCP response, we now know our address. So the address is giving to us on something called a lease, which may last on the order of minutes, hours, or days. And it's tied to the MAC address, or the address of our physical adapter on our device. Each Wi-Fi adapter or cellular adapter has a unique identifier then that allows the router or base station to keep track of the IP address that it gave us. That IP address then is ours until the lease expires. The net mask then and subnet tell us who can we find in the local area network or LAN without going to the global internet. So a net mask is a special kind of logic that tells us how many bits of the address that identify the whole of the local network versus just the part that identifies the device. Typically, these are listed something as 255 dot something, and these identifiers start from the left, and they tell us the subnet, or basically who are the people that I can find locally. For most of our communications on our smart devices, we're unlikely to find what we want locally, and we'll need to go out to the global internet. So every time our mobile device opens up a new flow, it first checks to see if it can be found locally via the net mask and subnet, and if not, then it knows it needs to send the packets to the gateway. We can think of this choice, send it locally or send it to the gateway, as the first rule for routing then across the internet. So the gateway is exactly like it sounds. It's the gateway that gets my data packets onto the internet and moves them towards its destination. Normal routing rules apply at the routers as we move along the path using the IP source and destination addresses to get the packets on their way. The gateway not only shuffles packets to and from the global internet, but it's also our first line of defense for my network or a potential point to do something interesting. In particular, it's important to highlight one of those tricky things that gateways tend to do, something called network address translation, or NATS. When we had talked earlier, I'd alluded that we were eventually running out of IPv4 addresses. This is not technically true anymore. We're already out, in part due to how we allocated IPv4 addresses early on. So the rules for addressing have two very special cases that we care about. There's two particular subnets that are known as private addresses and that are not globally accessible. 192.168.star and 10.star, also called 192.168.net or 10net. A private address is not actually publicly routable, so you couldn't actually send something out in the global internet towards that. But a gateway then can take that particular address and translate it, or the T in that, between a single public address that I share and the internal private addresses. In short, what NAT allows us to do is to take a host of devices, just think about how many devices you have at home, and allow them all to share one single public IP address. You could share this even in a house, a whole campus, or even a whole country. And what this allows us to do then is it's allowed IPv4 to keep operating longer. And with clever port and IP mapping, we can make this all go. The reason why we cover this is that more likely than not, your own IP address is already NATed. And whether you're on a Wi-Fi link or a cellular link, you're sitting behind a NAT. From an application development standpoint, this makes it a lot harder because your device is not really on the public internet. You can talk to the public internet or start and initiate things, but it can make developing applications actually quite frustrating. Now, the cloud has fortunately come along and made things a whole lot easier, as it provides a central meeting place then to make all of our communications possible.